Okay, page 15 and 16 of logic. Use a truth table to determine whether the statement not P and Q is equivalent to not P or not Q is a tautology. So you're getting probably pretty good at this. We're just going to start building, from the beginning to this. So like this seems to be one of the most important things. We need a not P, we need a not Q, and we're going to combine all these. Of course, we're going to start with the inputs P and Q, and P and Q are going to be like every single combination possible, which there are 4 different combinations, and there they are. And we do know we need not P and not Q for part of the tautology. We also need P and Q. So we'll do P and Q first. Remember, whenever you do an and is only true if both are true. So just that one's true, everything else is false. Okay. And then we'll do a not P and a not Q in order to build the second, the right side. Not P and not Q. So not P is just false, false, true, true. It's just the opposite of P. And not Q would be the false, true, which would just be the opposite of that. Okay. And then we would combine. And then to find the left side, we would need to do a not of P and Q. So we would take P and Q, which is there, and we would just invert everything. So we get false, true, true, true. And then now we're going to find the right side. So what we're going to do is we're going to or together not P and not Q. So we're going to be looking at not P and not Q, and we're just going to or those together. When you or together, if either one is true or if both are true, it's true. So those 3 would be true, and the first one, which is both false, we'd put false. And then now we're going to say, hey, is the left side equivalent to the right side? And guess what? It is. So, yeah, it's a tautology. Okay? Tautology, or it's valid. Okay? All right, number 3. Use truth tables to analyze the statement P and Q is equivalent to P. Okay, so there's 2 statements. One of them is here and one of them is here. Okay? So first we're going to do P and Q, just like we always do. And since there's P and Q, we know that there's 4 different combinations. There's true, true, false, false, and true, false, true, false. And okay, let's do the left side of the first one. It's P and Q. So P and Q we would write as double trues would be true and everything else is false, right? Okay, and now we can compare. Okay, so that's the left side. The right side is P. Let's compare the left side with the right side. Are they equivalent? And no, they're not. So no. Okay, now let's find P or Q. Okay, P or Q is true whenever either one is true. So the first 3 are true, and the last one is false. And so this is the right side, or the left side of the second one. Let's compare that to the right side, which is just P. It would be that compared to that. And is that also equivalent? No, it's also not equivalent. So this is also not equivalent. Okay? All right. Now it says, determine whether the statements not P or not Q and not P or and Q are equivalent. Okay, so basically they're saying, hey, are these equivalent? And so we're going to make first the inputs P and Q. First 2 true, second 2 false, and then we do true, false, just so that we can get every single combination represented here. We are going to need, to build these statements, we're going to need a not P and we're going to need a not Q. These are really easy to make, right? False, false, true, true for not P. False, true for not Q. Okay. And now I'm going to see, okay, P or not Q. So to build P or not Q, we take this and this. And since it's or, what we're going to do is look for if there's a true in either one, it's true. So this is true, and this is true. And since this one is double false, then this one is false. Okay? And for the last step, we need to put a not P or not Q. And then so we just invert all those. So it's false, false, true, false. Okay? So this is actually the left side now. And then the right side would be not P and Q. So we're gonna and together, not P and Q. So we're gonna and together those two. Whenever you and together something, the double trues are the only trues. So to be and, for the and to be true, both have to be true. Everything else is false. Okay, now we have the right side done. So now we're going to compare the left side and the right side. Are they equal? And they are. Look, false, false, true, false. So yes, they are equivalent. Okay. Number 7, determine the nature of the statement. Not P or Q is equivalent to P and Q. Okay, so we're going to put P and Q, and we're going to say true, true, false, false for P, and we're going to put true, false for Q. And then we're going to say, okay, let's evaluate P or Q, because that's what we need here. And then we'll take the not of that to evaluate the left side. Okay, so P or Q, anything that has one true or two trues in it is true, and then that would be false because it's a double false. Then we invert everything to do a not P or Q, and it would be like that. That's the left side. Now the right side would be P and Q. So that would be whenever both P and Q are both true, which is only the top one, and the others are all false, right? Okay, and then we're going to say, okay, are these equivalent? Is this equivalent to this? And they are not, so not equivalent. Okay, so it's not a tautology, it's not a contradiction, it's neither. Okay. There are 3 commonly used arguments that are formed from the direct statement P implies Q. Q implies P, which is called the converse of the original statement. Not P implies not Q, which is called the inverse. I should probably stop saying it. I was saying inverse before to change true to false, and I should stop saying that, right? Not Q implies not P, which is the contrapositive. Okay. All right, now copy and complete the truth table for the converse. Q implies P. So let's see. First we're going to fill in P and Q because, you know, we always fill it in the same way. That's fine. And then now we're going to see, okay, does Q imply P? Oops. Okay, so I'm not sure why they do that, but they ask us to repeat P again. And then we're going to say, okay, I guess this is to put it in the right order. Okay, so now we're going to say, does Q imply P, or does pink imply green? Okay, so if Q implies P, that means that when Q is true, then P is true. So this one is definitely valid. Now when Q is false, P can be anything. So this is fine and this is fine. What about when Q is true and P is false? No, that's invalid. Okay, so that's how that gets filled in, I guess. Okay, number 2. Copy and complete the truth table for the inverse, which is not P implies not Q. Okay, so again, the first part, we always fill it in the same way. True, true, false, false, true, false, true, false. And then the not P would be false, false, true, true. And the not Q would be false, true, true. And then not P implies not Q. Let's see, not P implies not Q. So when both are true, that's fine. When not P is false, then not Q can be anything, so those are both fine. And if not P is true and not Q is false, then that's bad, so we'll put a false there. Okay? Alright. Now copy and complete the truth table for the contrapositive, which is not Q implies not P. So again, we fill in the first 2 columns like that, and then the second column like, oops. like that. And then not Q is the inverse of that. Okay, and then not P is the inverse of that. Okay, and then we check, does not Q imply not P? And so if both are true, then that's definitely valid. If not Q is true, then that's fine because not P can be anything in that case. But if not Q is true and not P is false, then that's bad. That's invalid. Okay. So we've done the truth tables for contrapositive, for inverse, and for converse. And right now I don't have those memorized yet. That's okay. Okay, and I guess that's it for 15 and 16. All right?